All right, everyone. We're going to try this out, see if it works. Hopefully the screen is not too tiny. I'm trying my best to make it all fit. But anyway, today is lesson 10.5, simplifying rational expressions. What I can tell you about this is that it involves factoring. So if you remember the rules of factoring, if you remember the rules of simplifying exponents, this isn't too much of a stretch of a lesson. So if you take a look quickly at the warm-up, letter A, simplifying a basic fraction, like elementary school, 18 divided by 12. Most of you would probably reach for your calculator and math, enter. But if you wanted to look at the real way you should do this, is you would technically rewrite it. Oh, green pen not working. That's no bueno. Let's see. You would rewrite 18 as 6 times 3 over 12 as 6 times 2. Whatever you have a common factor of, you would cancel out and give you the answer of 3/2. Now, when it comes to something a little bit more difficult, like letter B, you're going to look to factor. So if you recall basic factoring, up top, we have an x squared minus 9. Now, x squared minus 9 factors into x minus 3, x plus 3, if you recall. And on the bottom, 2x plus 6, that's a GCF. You can take out a 2, and it would leave you with x plus 3. So once you're all factored, pretty much cross that out so you don't get confused. And any common factors, you can cancel out 1 for 1. So x plus 3 and x plus 3 would wipe out, leaving you with x minus 3 all over 2. And letter B is kind of like what we're going to lean towards on this lesson. It's just going to be more complicated with the factoring. But right in the beginning, let's just get ourselves used to simplifying. And if you look at exercise 2, we've done these problems before. So we've got some division. So the idea is you would take care of the coefficients first. And then whatever variables are the same, x's go with x's, y goes with y's, you can either use the rule of exponents, which says when you have a common base, subtract the exponents. Or if you guys recall from my class, we would talk about where you have more of. So like in letter A with x to the 5th over x to the 8th, you have 3 more x's in the bottom. So on the bottom, you would be left with x to the 3rd. So if you just take a minute to think about that, okay, you look at letter A. Letter A, if I wanted to simplify, I would take a look at the 3 and the 6. I know that the 3 and 6 would reduce into 1/2. So you could write a 1 and a 2 here. Now, again, I just talked about the x's. You have 5 x's on top. You have 8 on the bottom, which leaves you with 3 on the bottom. Now, where the y's are concerned, you have 6 of them up top, you have 3 of them on the bottom. So if you simplify, you have 3 y's up top. Now, if this was a multiple choice question on the Regents, which luckily for you guys, you're not taking this year, you would have y cubed over 2x cubed. And that would be your answer. They didn't specify no denominator or anything like that, or only positive powers. I mean, you could actually, if you use the rules of exponents, you would get x to the negative 3rd, y to the 3rd over 2. That would be the same answer. So both of these are the same. Okay, depending on what you were looking for or any kind of directions they gave you. So if you look at letter B, let's see what we got here. I got a 20 up top and a 4 on the bottom. That's going to leave me with a 5 up top. Where x's are concerned, I've got 10 up top, 2 on the bottom, which is going to leave me with x to the 8th up top. There are no other y's other than the y to the 8th up top. So your final answer, 5x to the 8th, y to the 8th, you're good to go. All right, looking at letter C, let's see what we got here. I go to simplify. Let me make sure I'm still in the screen. Okay, good. Let's see. Ooh. All right, I have 7 over 21. 7 will go into 21 3 times, so this is really 1/3. X cubed up top, x to the 5th on the bottom. That's going to leave me with x squared in the bottom. This y, remember, is y to the 1st, which means I have y to the 7th on the bottom. Make sure you have that 1 up top because you can't have it with nothing. So 3x squared y to the 7th is your answer. So that's a little bit of review. Why don't you guys take a look at the third exercise, maybe pause the video. I can't pause the video because it'll just end it for me. So if you want to pause and give it a shot, that's fine. If not, I'm just going to work it out quietly myself, and we'll give it a quick chat in a second. Looks like it's this guy right here. 10 divided by 15 is 2/3. 6x is up top, 2 on the bottom leaves you 4 up top. That's the big difference between 1 and 3. 1 and 3 are very similar. 1 uses the rules the wrong way. So choice 3 should be your answer. Now, not for nothing, if you were taking the Regents and you were in a jam, you could substitute in a number for X, substitute in a number for Y, and then get a crazy answer, and then do the same for the 4 choices. And once you got a match, you would find your answer. That's very time consuming, but it is an option. All right, so now we're going to get to the real good stuff. Okay, which starts with example 4 here. So now we're getting away from monomials. Monomials are where the terms don't have any pluses or minuses in them, which was an example, what was it, 2 and 3. Those were all monomial denominators. So example 4 is going to be a little bit different, but not impossible as long as you know how to factor. So I'm going to put some steps right here. The first thing you want to do is look to factor top and bottom, numerator and denominator. So look to factor all those. So if you look at the top in A, the top in A is a trinomial. So you want to multiply to a -14, add up to a +5. The two numbers that are going to do that would be a 7 and a 2. Bigger one is going to be positive. So x plus 7, x minus 2 would be your factoring. On the bottom, you have difference of perfect squares. So x minus 2, x plus 2. And like I said in the original opening warm-up problem, letter B, I said you would factor and then you would cancel any common factors. And you have to cancel, you know, one top one for a bottom one. So you cancel common factors. They have to be an exact match. So let's say I have an x minus 2 here and an x minus 2 here. That's going to leave me with x plus 7 on top and x plus 2 on the bottom. You can't cancel any further. Those x's cannot wipe out because you would violate a basic rule of algebra. That plus or minus in between them, they binds them together. So the only way to get rid of an x plus 7, you can only get rid of x plus 7. You can't just get rid of an x there. So I hope that makes sense. All right, letter B. We're going to look at that. Letter B is another, the numerator is a dots problem, right? Perfect square, perfect square, perfect square being subtracted. So just like the bottom in A, you square root your first term, square root your second term, 1 plus 1 minus. Remember, good times, right? On the bottom, 10x minus 5 looks like you have a GCF of 5. So 5 will go into 10x and leave you with 2x. Minus 5 goes into 5 one time. So now that you have factored everything you can, you get rid of common factors. So 2x minus 1 wipes out 2x minus 1 and leaves you with 2x plus 1 all over 5. All right, so looking at letter C. Letter C is a pain because if you guys recall, the numerator has a leading coefficient. So that's that type of factoring where you multiply first and last and put it in a box. I'll go through it here. There's also some of you that prefer to group that. Be my guest, but I'm going to go over my quick way. So let's see, my numerator. I'm going to come down here and attempt to factor it. So I'm out of the way. So I multiply my first and last, put it in a box. I want to multiply to 24. I want to add up to 14. Signs are the same, both positive. Two numbers that would do that would be 12 and 2. And then recall you would divide by your leading coefficient. And then you would reduce if you can. So this becomes 4 over 1. And then you would pop it into the parentheses. So for this 4 over 1, you would wind up with x plus 4. And for this 2/3, you'd wind up with 3x plus 2. I hope that's not that much of a stretch for you guys. You could always go back and look through your notes. We did do a whole unit on this type of factoring. Letter C on the bottom in the denominator, again, is a dots problem. So x minus 4, x plus 4. Cancel any common factors. So this x plus 4 is going to wipe out this x plus 4. So your final answer is going to be a 3x plus 2 on top, all over x minus 4. Okay, so hope you guys are doing okay with those. In example 5, exercise 5, we have a little bit of an issue here. This is a special case where you have the same terms just being subtracted and their positions are swapped. That's something that they do a lot of in this course. They look for it. It's a little bit of a trick. If you do the basic math here, you should be able to figure out what the rule is. So let's take a look at letter A. And if you just look to simplify on top, 9 minus 6 is going to give you a 3. 6 minus 9 on the bottom is going to give you a negative 3, which will reduce into a negative 1. Now, if you look at letter B, same idea, just different numbers. 15 minus 3 is 12. Over 3 minus 15 is negative 12. That also reduces into a negative 1. So if your terms are the same, you have a 15 and a 3 and a 15, being subtracted and in reverse order, it's always going to reduce to negative 1. So if you see something like let's see what I got here. Letter C, where you have A minus B over B minus A, you should be able to recognize just by looking at it. Same terms, different positions being subtracted, has to be subtracted. You can automatically simplify that to a negative 1. So let's take a look at a multiple choice question that's going to illustrate this property. So you're going to follow exactly what we did in example 4. You're going to look to factor the top and to factor the bottom. So if I look to factor the top, I'm going to get 2 parentheses x minus 5. So I have a GCF of 2. On the bottom, I have a dots problem, but be careful because the 25 comes first. So that's got to come first in your parentheses. So you have a 5 minus x and a 5 plus x. So now you recognize, oh, there's that property Mrs. Thornton was just talking about, x minus 5 over 5 minus x. So you're going to cancel them out, but what you're going to do is you're going to replace that with a negative 1. Now, what I want you guys to remember is up top, you're actually multiplying. So 2 times a negative 1 will give you a negative 2, all over 5 plus x. I'm just going to check the view, make sure you guys can see that. Okay, looks like it's still in view. Now, let's look at our choices. Our choices are a little weird. I'm looking for a 5 plus x on the bottom. Now, I don't have 5 plus x literally, but I do have its equivalent only in choice number 1. So now when you have a plus sign, remember, you can switch the terms because addition is commutative. So 5 plus x is the same as x plus 5. Therefore, choice 1 will be your answer. And that's the scoop there. So one last problem like that in exercise 7. I'm just going to do it, like I said, silently, and you guys can try it as well, and then we'll reconvene. You can pause the video if you want. Up to you. I'm just going to do my factoring down here. Up top, looks like I have signs are the same, both negative. We want to multiply to 9, add up to 6. So x minus 3, x minus 3. On the bottom, looks like I have a GCF. The biggest number that divides into 18 and 6 would be a 6. So when I pop that out, 6 goes into that 18 3 times, minus 6 goes into this 6 1 time, but leaves me with the x. So let's see what's going on here. X minus 3, 3 minus x gives me a negative 1. So let's see, I'm just going to write it out simply. Negative 1 times x minus 3 over 6. And I'm looking, and nothing is in that factored format. So the next thing you would want to do is possibly distribute that negative 1 through so that you can drop your parentheses. If you drop your parentheses, you're going to get negative x plus 3 over 6. Now, is that there? I don't see that. But what they did do, well, first of all, I would get rid of the 9 on the bottom. Now, the only thing I see is I have a plus sign, so with the fact that addition is commutative, I can switch their forms. Just remember, it's the positive 3 that goes in front, and now I'm going to have minus x when I reorder it. And that's all over 6, and that's your answer. So if you were kind of stuck between choice 1, 2, and 4, and you weren't really sure, you could just, at this step right here, you could plug in a number for x, evaluate it, get your answer, and then take that same value for x, plug it into choice 1, 2, and 4, and see which one gives you the match. So that's a scoop on 10.5. I hope you enjoyed my voice more than Kirk's voice, but who knows? It's been a while since I've talked to you all. Hope everyone is doing well, and like I said before, reach out if you have any questions whatsoever. I would suggest taking a look at the homework, picking a few choices, trying them out, and then go back and check the answer key and make sure you're doing things correctly. If you're not, again, reach out. It's probably just a minor error with usually with factoring. All right, have a great day, guys.